Hello, everyone. Good morning, good day, good afternoon. My name is Milan from the marketing team, and I'm very excited to open the third and the last day of this amazing conference, Knowledge Graph Forum 2023, organized from Ontotext and the partner ecosystem we are building. So very excited. Just quick housekeeping, and I will present our third keynotes for the conference. I will share my screen just to give you information about the lobby and your experience, what you should what you should expect if you're here for the first time. So this is the lobby. We are making announcements here for the upcoming sessions. Here there is a pop-up banner that you can click and join the session immediately. The main stage session is here. The expo session on the left sidebar, you can visit the virtual booths of all of the partners. We have prepared good materials for you. You can jump into a chat with someone from the representatives. Also, there is tab people where you can basically search for people, companies, and make personal connections. And networking tab, this will be during the break. You will have chance to make a speed network with random people. It's such a fun. I tested it twice, found new and also old connections. So on the other side, there is on the right side, there is a poll option chat with everyone in the forum, everyone who is live. Don't forget that the recordings will be available right after each session, so you can immediately rewatch the session if it's very interesting for you. And also in every session, you can find the presentation just below the video player and the information about the session. So with that, I stop sharing, and I want to present you my dear colleague Brandon Richard, who is General Manager for APAC region with Ontotext. Brandon will tell his very interesting story about the converge between RDF and property graph for enterprise data management. Brandon, the stage is yours. I disappear now and appear again for the Q&A after your session. Good luck, man.
Thank you. Let's see. Hopefully my screen is showing here. All right.
Yes, you are live.
All right. Well, hello and welcome to day 3 of the Knowledge Graph Forum. As Milan said, my name is Brandon Richards, and I'm the General Manager for APAC at Ontotext. My topic today is an important one. Thinking more strategically about graph technologies and how RDF and labeled property graphs will fit into that bigger picture. So a little bit about my background. I spent 7.5 years building up Neo4j's APAC business from scratch. I've now been at Ontotext for a little less than a year doing the same thing. So I've worked with literally hundreds of enterprises on their graph technology journey, both on the RDF side and on the labeled property graph side. So I'm very, very familiar with real world deployments, the successes, the struggles, the use cases and the projects. And I hope that I can share some insights today that will be helpful to you as you navigate your own organization's graph technology journey. So I'd like to start with the story of SpaceX and the power of reusable rockets. Now, you may recall several years ago, prior to the existence of SpaceX, the idea of reusable rockets was viewed as non-feasible. NASA and other aerospace organizations would build a rocket, fly it once, and that was it. Imagine building a 747, flying it once across the world, and then destroying it afterwards. That's the equivalent of what was happening. Now, love him or hate him, Elon Musk had some thoughts about this at that time. And here's what he said. He said, it's really crazy we're building these sophisticated rockets and then crash them every time they fly. This is mad. I can't emphasize how profound this is and how important reusability is. If one can figure out how to effectively reuse rockets, just like airplanes, the cost of access to space will be reduced by as much as a factor of 100. So, of course, you probably know the story. SpaceX succeeded in building reusable rockets, at least for the first stage rockets, drastically reducing the cost to send these payloads like satellites into orbit or taking astronauts to the International Space Station. And it was just a few days ago, they broke a record sending the same Falcon 9 first stage rocket on its 18th trip into space. I remember the first time I saw them landing 2 rockets at the same time. And it's become this testament to the power of innovation, right? In fact, this innovation has enabled SpaceX to have a massive cost advantage at getting satellites into orbit, which is translated into having more satellites in space than the rest of the world combined. And these numbers actually are a little dated. I believe they are now over 5,000 satellites. So they are far above the threshold of what everyone else has. Building reusable rockets was incredibly difficult. Many thought it was impossible. After all, if the folks at NASA hadn't figured it out, how could a small startup like SpaceX pull it off? But they did it, and it has changed the economics of getting to space forever. It wasn't easy. They had to figure it out from scratch. It would take time and effort, and it was certainly a lot easier to just build a rocket that you would use only once. But there were huge rewards for succeeding in reusability. But this is not a conference on aerospace, right? This is a knowledge graph conference. So we're talking about the power of reusable graphs. No doubt building a reusable rocket is harder than building a reusable graph, but many of the same principles apply. The good news is that you don't need to figure out this from scratch. Building reusable graphs is a solved problem. It's like licensing the technology for reusable rockets from SpaceX rather than figuring it out from scratch. But it still requires more effort than building a graph that is single purpose, like a labeled property graph, where you can whiteboard your graph model in an hour. If you take the time to work through a unified conceptual model based on both industry and semantic standards, controlled vocabularies, merging the relevant ontologies and taxonomies, yes, it will take time and thoughtfulness to do this, but the payoff is massive, especially in the context of doing a more strategic graph deployment across an organization. So let's zoom out for a bit. Every organization wants to be data-driven. The goal is to capture data, convert it into the right insights, and integrate those insights quickly and efficiently into your business decisions and processes. Companies that do this well have a significant competitive advantage over their peers. They can adapt to market conditions quicker and so forth. However, this process of converting data to the right insights is easier said than done. There are many challenges across this entire process. Firstly, let's look at the data side. All organizations are on a data journey. On the data maturity spectrum, the vast majority of organizations I've spoken with are stuck in this information stage. So they have massive amounts of data that they're collecting and storing in their relational databases, their document stores, their data lakes and data warehouses, and so forth. But until they connect the dots across their data, they will be stuck. And this is where graph technologies come in. Graph technologies allow you to connect the dots across your data and progress on the spectrum towards knowledge, insight, and wisdom. In order to do all the things you want to do with data without first connecting the dots, you will have subpar results. And this includes, big news flash, the AI space, right? Large language models, for example. You haven't connected the data first, you're going to run into certain challenges. Now, for this reason, graph technologies have taken center stage in the data and analytics space as a critical enabler. I have a few quotes from Gartner to illustrate this point. The first one, using graph techniques at scale will form the foundation of modern data and analytics. The foundation of modern data and analytics. I think that one's really powerful. The next one, by 2025, graph technologies will be used in 80% of data and analytics innovations, up from 10% in 2021. We see that 50% of Gartner inquiries on the topic of AI involve a discussion of the use of graph technology. Now, part of the reason for this is that connections in data and context around data are critical in improving AI outcomes. Often the relationships are the more predictive elements in the data. It also makes things like explainability possible, getting away from the black box problem. And the last quote is illustrating the idea that graphs are a key enabler of all of the other things you want to do in data and analytics, right? So graphs relate to and enable many of our current and past trends, including data fabric, natural language processing, the rise of the augmented consumer, X analytics, and smarter, more responsible, and more scalable AI. So before you can really maximize the value from data, you must first connect the dots. This message has been getting through, and most large organizations have at least a couple of graph use cases deployed. Some of the more mature ones have several use cases deployed. However, deploying one use case at a time as different teams discover graph technology will be slow and costly. Becoming data-driven will also be slow and costly. Streamlining that process of capturing data, converting it into the right insights, and then quickly and efficiently implementing them into your business decisions and processes, right? This happenstance approach may eventually get them to a reasonable data maturity level, but at what cost? There are hard costs as well as massive opportunity costs at play here. So until C-level executives start to take graph technologies more seriously, they're going to continue to struggle to deliver on the promises of their digital transformations and becoming data-driven. Organizations that understand that they have a data problem can take a more strategic approach, where they systematically identify the top use cases for their industry and prioritize them based on their key initiatives and organizational objectives. You can think of it as plotting the value an organization derives from its data over time. Every time they deploy a graph use case, it's like adding an S-curve, right? So each additional graph use case increases the value derived and shows up as another blip, a bump, a jump in this curve, right? So every graph use case is another S-curve. So where does this additional value come from? Why are we getting these big jumps? Well, it comes from a combination of a few things. Reducing costs, adding new capabilities, and reducing risk. And within each of those, there's a lot we could go into. We just don't have time for it today. But if you zoom out, not every graph use case is of equal value to the organization. Some S-curves can be more steep and dramatic, while others may be more modest. Some may help one team, while others may help the entire organization at large. So if an enterprise was more strategic, they would be looking at prioritizing and deploying these possible graph use cases based on the broader impact to the organization. Of course, this would require a more centralized approach. It would require a very senior level of sponsorship within the organization, almost certainly in the C-suite. To deliver this, you're going to need a team that understands the different graph use cases within their industry and be able to communicate and evangelize this across the organization. It would be a team that would possess the key technical skill sets, understand and capture the best practices around graph deployments, know which use cases are RDF, labeled property graph, or hybrid. There'd be economies of scale, an ability to deploy each successive use case faster and cheaper than the previous one. By doing this in a centralized fashion, an organization could maximize this graph opportunity within their organization. This would be what we call a graph center of excellence. So we could spend an entire session, half hour, an hour maybe, on the graph COE. What it is, how it should operate, which use cases to begin with, what skill sets and roles are needed. For a quick summary, these are the key points. A graph COE, Center of Excellence, will manage the strategic prioritization of graph use cases across the organization. As I mentioned previously, this will require C-suite sponsorship. It may start with a single C-level executive, but for this to truly succeed, there will need to be broad consensus across the C-suite that this is a strategic initiative for the organization. CEOs will get it, and so will CFOs, CIOs, CMOs, CDOs, and others. They all understand the need for operating with the best possible data and insights, and getting those insights as close to real time as possible. Without the highest levels of sponsorship, you're going to have limited success in overcoming organizational inertia. I'm sure many can testify to that, which brings up the key point of effective communication. Selling the value of connected data to data owners and executives across the org, and sharing the value of the quick wins or incremental wins. The COE would also have the key technical skills needed to deploy these projects, like ontologists, semantic engineers, data architects and modelers, domain experts. They would need to be able to bring in the best practices from outside, industry best practices, while capturing learnings internally. At least initially, they will need to start small and get quick incremental wins, demonstrate that value to keep the momentum flowing. And ultimately, they would be able to benefit from economies of scale, saving the organization time, money, and effort by doing this in a centralized way. Their first mission will be to build a reusable, foundational semantic graph layer across the organization's data. Now, this may all sound great, but how do we build a business case to get started? So far, our discussion's been pretty theoretical. So we need something concrete to justify moving in this direction. This is where the bad data tax comes in. In the race to become data-driven, most efforts have resulted in a tangled web of data integrations and reconciliations across a sea of data silos that adds up to between 40 and 60% of an enterprise annual technology spend. 40 to 60% of their annual technology spend. We call this the bad data tax. The larger and more complex data environments we see this closer to kind of a 60% range, while those that are less complex may be closer to the 40% range. However, if this wasn't bad enough, not only is this expensive, but the results often don't translate into the key insights needed to deliver better business decisions or more efficient processes. If you paid the bad data tax and it actually worked in making your organization data-driven, then maybe the cost is worth it, arguably. But what we're seeing is that even with this massive spend on moving and integrating data, reconciling and validating, the results are quite subpar. We can do better. This is the solid business justification every organization needs to fix their data. The cost of solving this problem is a small fraction of what they spend each year on the bad data tax. For some organizations with very large IT budgets, this bad data tax can be in the hundreds of millions of dollars every year. Yet, the solution is relatively simple. Build a foundational semantic graph layer across your data. It reduces or even eliminates this key bottleneck in the process of becoming a data-driven organization. For those who need access to the data in order to convert it into the right insights to drive business decisions and processes, they need the data to be available and accessible when needed. Stored in a format that is flexible, accurate, and machine readable, it must retain the context and insight of the original data and be traceable as it flows through the organization. My friend and colleague, Michael Atkin, refers to this as the Data Bill of Rights. Myself, Michael Atkin, and Summit Pal, Summit, who spoke yesterday as the keynote speaker, have published a paper on the bad data tax, which you can find on our website. For these reasons, this reusable, and that is the key, reusable graph foundational layer with a shared conceptual model will need to be built on RDF. LPGs and RDFs are clearly optimized for different use cases, but this is one of those use cases that falls squarely on RDF. That brings us to the age-old graph technologies holy war, the battle, right, between RDF and LPG. Organizations looking to leverage graph technologies have ended up in these hotly contested battles, internal debates over the resource description framework, or RDF, versus labeled property graphs, or LPGs. But I think we're looking at this all the wrong way. The idea that you must choose between them is simply wrong, that you must choose either one or the other. This is the logical fallacy of a false dichotomy. This idea that an organization must decide either or is absolutely wrong. An organization doesn't need to choose between the two. In fact, not only are there more organizations choosing to use both, but there's been an increase in the number of projects using both, each being leveraged for their strengths. Each is really optimized for very different things. Yes, they both have graph databases. Yes, you can make knowledge graphs with each, but they're used very differently. And it turns out there's very little overlap when you actually look at it. There's far too much to unpack in a short presentation like this, but I might summarize it in this way. RDF tends to be more data and metadata centric. And what I mean by that is that there's tooling around data hygiene and enrichment. We're putting additional effort around controlled vocabularies, using IRIs to resolve entities, leveraging linked open data to enrich metadata. You're managing complex ontologies and taxonomies, which, by the way, may be coming from industry collaboration. Shared industry ontologies are typically in RDF native formats. Additionally, we're going to take multiple ontologies and merge them together. All of this upfront work pays off in the end. You're building a standard for the organization, something that can be used and reused over and over again for a wide range of use cases. The reusability is a key feature here, as well as having interoperability across the org or even the industry. Now, on the label property graph side, the approach is typically very different. Usually there's a specific use case that it's being deployed, such as something like real-time fraud detection, or I'm going to build a special recommendation engine.
Graph model is developed on a whiteboard.
Right?
They go and they plot out what are my nodes for this graph to be able to solve this very specific problem. They don't tend to care about industry or even company standards necessarily.
Right? The model will be optimized for the queries that they're trying to answer. This means that it can be deployed very quickly. You develop the graph model, load the data into the model from your data sources, write your queries, tune the model, and there you go. It can be deployed in a few weeks. However, there are many instances where labeled property graph deployments can greatly benefit from all the upfront work done on the RDF side. Firstly, we all know the idea of garbage in, garbage out. If the groundwork of data hygiene, data governance, data provenance, and lineage has all been done on the RDF side, this can greatly improve the outcomes of the LPG use case. Not only that, but by integrating with RDF, they can pull relevant portions of the unified ontologies and taxonomies into the label property graph, thereby making it less like a graph silo and more interoperable across the organization or industry. For text analysis use cases, label property graphs often have the text analysis side done on the RDF side, right? and then they pull it into the labeled property graph. With the advent of large language models, LPGs may be less reliant on RDF to do the text analysis, but that would also come at a cost, losing the context, explainability, etc., that comes from the graph structure in the RDF. The key takeaway here is that RDF and LPGs can complement each other quite nicely. The use of RDFs can greatly improve outcomes and even speed of deployment of labeled property graphs. So in what way are labeled property graphs and RDFs better together? Well, we start with what a labeled property graph needs for optimal outcomes. We mentioned that labeled property graphs are typically built around a specific use case. Typically, they start with understanding the questions you want the graph to answer, and based on that specific use case. You need to figure out what data is needed and how to best model that data as a graph. What are your nodes, relationships, properties, as I've already mentioned. Once that's determined, you can begin to ingest data. The key here is that for optimal outcomes with labeled property graphs, you need to ingest good, high-quality data. The same principles of garbage in, garbage out, right? That applies to the graph space. So when we look at how RDF can make LPG better, it's because we can feed the LPG with higher quality data, the unified conceptual models with the ontologies and taxonomies, or at least the portions of the ontologies that will be useful in the labeled property graph use case. We also have the controlled vocabularies and better data hygiene with data validation. We can enrich the data with and metadata with linked open data. The data can be NLP and text analysis ready. All of that happens on the RDF side. This means that feeding an LPG with an RDF graph will feed the LPG with higher quality data, but it will also bring in better integration and interoperability. The labeled property graph will no longer be a graph silo, right, that we're adding to our infrastructure, but it will share the same meaning and context with the rest of the organization. It will use the same unified conceptual models, ontologies, taxonomies, controlled vocabularies, and so forth across the organization so that everything is speaking effectively the same language. Especially for cases with complex ontologies and taxonomies, the labeled property graph will benefit from a speedier deployment, capturing that rich context from the RDF. And lastly, when you have higher quality data, you'll see better outcomes. So coming back to our bad data tax use case, RDF lays that foundation, and then you can have all kinds of RDF and labeled property graph use cases served by this foundational layer. This is the basic architecture of using a foundational semantic graph layer to resolve the bad data tax, where we have at the bottom the sea of data silos. We have our data catalogs above that, and then we map these data catalogs to our semantic graph layer with its unified models and schemas, ontologies and taxonomies, and controlled vocabularies. Then all of our downstream applications can access this semantic graph layer for various use cases. That includes, as I mentioned, labeled property graph or RDF graph use cases, or the development and evolution of data products, where the goal is delivering trusted data and converting it into insight that can be quickly and efficiently integrated into these business decisions and processes. Building this foundational layer would be the first mission of the Graph Center of Excellence. Then other graph use cases would benefit from the economies of scale, whether they are RDF or LPG use cases. So in conclusion, I have a few key takeaways. There are massive benefits to reusability. Yes, it will take more time, but the payoff is worth it. The reusable graph opens new possibilities for more strategic deployment of graph technologies across an organization. Graph technologies are a critical enabler of all the things you want to do or be able to do in data and analytics, effectively connecting those dots across your data in the quest to becoming a data-driven organization. Rather than implementing graph technologies one use case at a time, haphazardly, taking a more strategic approach by forming a Graph Center of Excellence will help organizations achieve this data-driven goals significantly faster and cheaper. Next, establish a Graph Center of Excellence. We're going to be publishing a framework for how to do this in greater detail in the coming weeks. The bad data tax of 40 to 60% of your IT spend is a compelling business justification to build a semantic graph foundation, which then can be used to deploy other graph use cases quicker and cheaper. It's a small fraction of the cost, but the payoff is massive. And as an organization, you do not need to choose either labeled property graph or RDF. A robust graph strategy will incorporate use cases for both. Each is optimized for different things with very little overlap. They integrate easily, use the right tool for the right job, each for what they're optimized for. And for some instances, they may even work better together in the same use case. Thank you.
Thank you, Brandon. Amazing presentation. You received so much love from the audience, but unfortunately, we don't have any time for additional questions. The next presentation just started, so if you have any questions, audience, please share it. Come and visit to our booth and share it with us. I will answer you almost immediately. Bye from now, Brandon. Amazing again. Thank you very much. Thank you for your presentation.
Yeah, thank you for having me.